Okay, and welcome. I am the database guy, and again, please like and subscribe. Welcome again to our third presentation, video one. I'm sorry, and this is a SQL Server MS Access database development. We look at our ongoing curriculum here, or curriculum. We're on the third bullet point of database design, and when I get into tables, I think what I'm going to do is be very careful of how I design that presentation because, as you'll see later, I don't want to confuse you. But anyway, today in database design, we'll have basic concepts. We'll have the normalization. We're going to look at that in general. You could do a whole course on normalization, and it gets a little crazy what this concept is. But every database should be normalized to make sure that it's storing data efficiently. Then there's the developer's goals that we want, and the Horn of Plenty, my design. I've done that from years ago, and something about life expectancy of a database. Now, you've seen this before. Again, your front end is a graphic user interface. You have tables, queries, forms, reports, and code. Now, be aware that tables in the front end are not the same tables in the back end. And that's where, when I do that presentation on tables, when we get to that, we got to be clear on that. So what you store in the back end is where you're going to store your data. The other tables are just ancillary and tables that are there for use for the GUI. So you can either have 2.2 gigabyte limit in MS Access in your backend tables, or 10 gigabyte in SQL Express, or the size of your drive with SQL Server, all of that on the backend table. So you've seen this before. The point is that this design is very, very important, and we're going to see that because here, data integrity is everything. Without it, we are essentially, we can lose data. We don't want to do that. At 17 years doing this in industry and privately working for clients, I've never had a loss of data ever. Uh, what would happen would be this: if you tried to design everything in one file in Microsoft Access, and you could only do it with Access, the front end and the back end in one file, you could do that. You could have all those tables there. If there's a corruption in your graphic user interface, a form, a report, something of that nature, even code, and you can't open your database, you've lost your data. So that's why this front end back end model is so important. Right? Then we go to robust performance, efficient developing, and the table schema is everything. You're building a house, the foundation, if it's not strong, it's going to collapse. And so your table schema essentially is the foundation of your database. And it must be designed in such a way that you can maximize the storage of your data while minimizing the amount of space you need to store it, and also make sure it's efficient. And then, of course, correct VBA coding, and that's very important. Too much code or too much awkward code can lead to a lot of errors, even if you error trap it. You want to make sure less is more, and you're going to see that. And then, of course, query design, extremely important here, in that how you design your queries, how you design them to ensure that you can feed your forms and reports efficiently, or get data. For example, if I were getting data from SQL Express or SQL Server and I wanted it directly, and it's a good amount of data, I would do a pass-through query. I would write my SQL as you would write it in SQL Server, which is the same thing as Express. And I would do that from Access. You're allowed to write a pass-through query, and you get the data directly from SQL Express or SQL Server without going through Access. And I can't tell you how many times I've seen developers go through Access. It takes a long time to get the data, and it doesn't make any sense. So how you design your queries, how you design them to do and manipulate the data is extremely important. All right. Then there are forms and reports. That design as well. The controls within them, less is more. There are some reasons where you might have a lot of controls. You might have a good number of controls within that. So um, one example might be, and a lot of the clients want a nice menu-driven, what used to be called a switchboard. I don't believe in switchboards anymore. I say stay away from them. You have two options. You have either creating your own ribbon, or you can have, and the last two clients I've had have wanted this sort of menu-driven navigational control with tabs and things of that nature to access their data, which is fine. And when you have something like that, a menu-driven form, having a lot of controls is expected. But just, again, less is typically more. And then, of course, dependability, thoughtful developing. You want the ease of data entry. You don't want your users, your end users, to sit there forever and enter data. That's not working for them. It's not working for anybody. So you generally want to have drop downs and um, list boxes and things of that nature, controls that you can easily select data. Um, you want to have certain types of radio buttons and checkboxes maybe, but you want to standardize that input and make it very quick, effective, and easy. And then you want to search for anything you can out at the end of it, at the the data consumption part. Search, report, do whatever you need, right? Get it out as much as possible because that's the whole point of this. And then, of course, intuitive and simple graphic user interface. You don't want complex concepts. You want to have a pathway based upon the requirements. You want to make sure you understand what the database is going to be used for and how to get from point A to point B to point C, and something that the end user, when they look at it, will know quickly from just looking at it what they need to do. So we get to normalization. Definition here, process of organizing data in a database. Generally speaking, we want to have it organized in such a way where it is extremely efficient. So no replication of data should exist. I talked about this briefly, but for example, if I'm saving a person's first and last name in every entry I am making, I am not normalized. If I have them in a customer's table, well, that's just fine. It only happens once. And if I need to make a change, somebody gets married or whatever the case may be, to that name, I can change it once and it will just completely propagate throughout the whole application. I never want to have a situation where I have replicated data. Another example, and you're going to see this one, is publishers for books. I don't want to store every single publisher's name in a field because that's taking up a lot of data. And again, if the publisher should merge with somebody and change its name, then I've got to change all of those entries. So that's a big one. Also, relationships must exist. You must have relationships. It's the third dimension in database design. You look at Excel, there's no relationships there. We just have a list of data, and we're basically filtering it. So getting that information out and being able to then get it out, seeing every book a publisher or as part of has been published by a particular publisher would not happen in Excel. It really wouldn't happen. You just filter out for the publisher you wanted, which isn't really a database. So that's extremely important. And of course, we're getting to the point of we want to minimize the storage of data. When you get the schema correct, you're going to maximize the amount of data you can store and minimize the entire storage capability by doing that. And you're going to see this in a moment. And also, you want to fully understand the object-oriented object attribute relationship in table creation. Now, all Windows-based applications are object-oriented. They're designed with object-oriented platforms. Word, Excel, Access, think about it. A table's an object. A table has attributes. It has fields. A field is an object. A field has attributes. It has data types, and so on and so forth. I mean, you can go on and on and on. But when I get to this point here, what I'm saying is, if I'm looking at books again, what's an attribute of books? Well, I could have write a title. I could have a year that it was published. I could have the publisher, the author or authors, Those are attributes of books, but they're not. You've got to be careful how you store that information. You really, really do. Okay. So again, understanding that you're going to see it. And then, of course, the last one, we don't ever want to store calculated or concatenated data. If you can calculate data in your database, all right, the moment you store it, you're taking a snapshot of that. So if the data changes, the calculation does not. And that's going to break the normalization of your database. You don't want that. You always want to calculate data on the fly. There's no point to storing a calculated value. It's a bad thing to do. And the same thing goes for concatenated. If I have a first and last name, I never want to store a full name because that, in a sense, is the same thing. If it ever changes, it's not going to be something you want to do. All right. The developer's goal, right? Develop a database that meets the following, right? You got to meet business requirements. I call them business requirements. They may be personal requirements, but whatever the person's. So if you have a client who needs a database for some reason, and it's they may be their requirements, but still it's within the business of what they're doing. So I call it business requirements. You have two types. A user requirement, which is needed by the end user. A great example of this might be, I need to enter dates, a start date and an end date. I need to have a date picker, okay, which is easy enough to do. As part of it's part really of a text box. You can create it as a date picker. But on the other side of that, I've got to make sure that the end date is not less than my start date, and my start date does not exceed my end date. Because then I can get into problems with that, all right? Versus a functional requirement is something that the database needs to function in general to run properly. So I'll give you an example of that one from a client, importing data, right? How do you prevent somebody from importing the same data twice? The requirement is, functional one is that they can import data, but they can only do it once. Well, in this particular client's case, they're storing the data, the imported or the audit trail of what's being imported, so we know what file names are being imported. And to that, I can compare that file name from that table against the file name that they select from the file dialog. And if they match, I can say, sorry, you're not importing that. It won't work. It's already been imported. So that's very important to an application to run properly. Otherwise, you're going to get duplicate, triplicate data. And then, of course, you have flawless testing, right? Ensuring that each area developed is tested with expectant data. Always use data you expect in the real world for your client. Never try testing with data you wouldn't want to see. That way you can determine that, yes, it does work. If I'm importing data or if I'm manipulating data, it will work. And your graphic user interface functionality has a deliberate workflow. So if somebody wants to not delete something, but edit something or save something or add something, you confirm it. We never really want to delete data, and I'll explain that one at some point soon so you understand why. There's no reason to delete data from a database. And of course, minimal VBA coding. As I said, less is always more. So it runs efficiently. This is the Horner planning. I designed this many, many years ago to illustrate what each phase of the database should look like visually and how it should be developed. You notice the data input is a fixed line and it's a fixed width and fixed length. In other words, what I'm being conveying to you is that you should have standardized data input that is robust, efficient, and it's not time consuming so that the end users can get the data in quickly. The data storage part of it, you notice, is not solid, it's dashed, but it's also not touching. It's not a full box because it's always growing. However, it has sort of a finite size in its width, or actually I should say its length, not its width. In other words, you should know what your table schema is. You should know, and that's really reflecting what an illustration of what the table schema should be. We should have a definite table schema of certain length, but it will always it will always grow as we fill data in there, and that's the point of that. And on the last part, the data consumption end of this here, the horn itself, you notice it's dashed as well, but it's a finer dashing because it indicates it is growing, but also that line at the end never touches the horn, meaning that we can always expand our ability to search for data by adding more reports and queries, and it should be maximized. That's the whole point of that. We should maximize the consumption, and it's the best way I can look at that. I could have probably drawn a box that just continually grows, very much like the data storage, but it wouldn't be right. Here, you're basically at a point where you do have a certain maximum capability to search, but you can always expand it little by little if you want more within it. So it's never really completely finite. And then, of course, our development life expectancy scheme here. We start with a concept like designing our database or figuring out what our database will be. Then we design it. So we have a concept of what we want for a database. We design it. We develop each portion of it. We test it. We deploy it. We upgrade it. Once we go to the upgrade portion, we're going to have a concept for what that upgrade will be. We'll design that upgrade. We'll develop it and test and deploy. And it keeps going around and around and around. So it's always a life cycle that exists from cradle to retirement. Okay. MS Access will be around as Microsoft continues to improve it. Now, I've heard people say it's going to go away. I don't see it going away. I just don't. People use it. People need it. And businesses use it, but they don't use it to its full potential because no one knows really how to. They don't really know how to use it. They don't know how to develop into it. It's a very complex platform, and people don't want to put the time into it. I'm going to show you because I'm putting the time into it right now. So anyway, it's currently part of Office 365, which is $99 a year for a family plan, which gives you 5 users, I think it is. And as I said, cradle to retirement. And once your next phase away from this, when you couldn't do this anymore, and I've seen people do it, I've been part of it in industry, is working with Visual Studio to design a web-based application and then use either SQL Server or Oracle as a back end. Now, I'm going to forewarn you that while a web-based application is yummy and nice, it takes a lot of work to do that because you have to work with GitHub or something that will store all of your code in branches. And once that code has been verified that it works and is good, it can be merged. But it's a lengthy process. It's a costly process in many ways because SQL Server and Oracle require licenses. The Visual Studio is generally free for personal use, but if your company makes more than $1 million a year, it must come off your computer. I had an instance of that. Didn't even know that that was the case, but nobody gave me a problem with it. Just get it off your computer, and I did, which to me is foolish. It really is. I think it's more of a monetary thing that Microsoft doesn't want a company that's making a lot of money not to pay them. But then again, I'm not sure of it, so I'm not going to comment on that any further. But in any event, this kind of thing, if you want to go to it, great, but it's going to require a lot of personnel to code. You have C# or maybe C++, whichever one you want to work with. There's JavaScript, which I know as well, C#. And then there's, of course, Ajax, another small kind of coding technology that's there. You might also use, depending upon how you develop Visual Basic, which is not the same as Visual Basic for applications. It's similar, but not exactly the same. So depending on how you develop it within the Visual Studio application, again, and that is based upon something almost identical, just on a side note here, to developing applications, iOS applications for Apple, things like the iPad, and Apple also has the MacBooks and things like that. You have this 3-part developing concept, which is the view, the let's see, the view. What you see is the view. Then you have the control, or I think it's the control, and then there's the what the code that fills in the view. There's 3 points of that, and I just can't think of it off the top of my head. But anyway, you can look it up if you want. So view is one of those things, and then the controller. I'm sorry, the view, the controller, and there's one more. Um, it's an interesting way to program. I like it, but it does have challenges. In any event, okay. So let us go into Access. And we're in the table books here. I've got some books in here, and to show you my example here of trying to actually store a publisher's name or something that should not be stored, right? So what I'm going to do here is close this down, create another table. And remember, when we were in here, we went into table, and remember we created our table here, our very first one here. We're not going to do it here. We're going to go to create in table design, which to me is a better way to do things. I like it here. All right, we're going to use auto number for it, and pub. And then, of course, our short text. So these two fields we have here, one is going to be the ID of the publisher, and one's going to be the publisher's name. You say, well, wait a minute, you just told me not to store the publisher's name. Right, if I'm storing it in the books field, I'm going to replicate it like madness. But if I store it here, I only have one entry. So while we're at it, I'm going to, do you want to save it? Yes, I do. We're going to call this TB and pub. And now it's going to say that there's no primary key defined. I'm going to click cancel right now. And I'm going to right click here and select the primary key. Now the primary key, what is that? We talked about that with the books. If we look in the books table, we have a primary key here. I believe it's the book ID. Yeah, it is. So we go to design here. Yeah. Oh, it's in there. Okay. We would probably use, I'm going to just change this to ISBN, which is really the number that should be. It wouldn't be an auto number, but we're going to leave it as auto number for the time being, just for the sake of argument. But here, in this case, we are going to just have these two fields in this table, and we're going to save this. Yes, we want to save it. And TBL pub, it's already in there, so we're going to save it as that. And off we go. So we come back here to design view, and I'm just going to go to my publishers. I'm sorry, wrong one, into my books. Sorry about that. We go over to the publishers field here to the lookup. All right. And we use a combo box. All right. Now, you wouldn't do this in a normal database, but we're going to do it here. Our table query we're going to use, whoops, I don't want that. I'm sorry, hit the wrong thing. I basically hit the ellipsis here to go into a SQL. And I'll show you that at some other time, but we're going to select table pub, we just created. All right. And what I'm going to do here is save this just so you can see what happens each step of the way. So now coming off of here, let's see. Let me do it from here and see if I don't see anything on here. So we're going to go back to table books. We're going to go to our pub. Did it save it? Let's see. It did. Oh, we don't have anything in table. I'll tell you why. We don't have anything in table pub. I never added anything, so there's nothing there. So we're going to put this as pub 1, pub 2, and of course pub 3. All right, that's why. There's no data in there, so there's nothing to report. So we're going to come back to books again, and I'm going to show you. There's 1, 2, 3. So what I'm seeing here right now is the 3 auto numbers for the publisher, which mean nothing to an end user. But you would see this, you would show this in some form in your graphic user interface for data entry, but not through the table. So now what I'm going to do for a moment here is I'm going to go back into table books. All right. And I am going to go to my field pub. And now I'm going to do a column count of 2, not 1. Column count of 2. And let's see what happens with that, shall we? Whoops, sorry. Yeah, we'll save that. So now we see both the number and the publisher's name, which is really not what we want to see anyway, right? We're going to go back in here one more time. You can see this stepwise. That's why I want to do this. Go to our lookup here, and so bound column is 1, column count is 2, but I don't want to see the first column, so my width will be 0, but I want to see the second column. My width will be 1. When I click out of that, you'll see that they're in inches, all right? I'm going to hit the save button right up here. I don't have to save it each time I close it. We're going to open it back up. All right. And now you can see I'm fine. All right, everything is great. I can select my publisher without having to enter it. And I can't add another one. So if I go to publisher 4, watch what happens. I think it won't allow me to do it. Yeah, not in the list, right? Not in the list. I can't do that, which is good. So the list in this case, since it's through the table, you cannot add. In the forms, you'll be able to allow the user to add, be able to check what's being added, so forth, and so on and so forth. So right now, I have no relationships in this table. No relationships to these tables, right? None whatsoever. So why is it that, why couldn't I just leave it like this? Just select the publisher and go with it. Well, I could, but if I do that, I'm not going to be able to list all the books by a given publisher. I might have to do a search for that, and I can do it, but it's going to be like Excel. I don't want to do that. So what I'm going to do here, I'm going to change this to a number. Now, when I save this, I'm going to get a nice big error, because what's going to happen is, not an error, but I mean it's going to warn me. So we're going to do a save here. It's going to say that some data may be lost, because you can't take that numerical data, text data, convert it to numerical data. Yep, and of course it's going to lose it. So if we come back in here, we're going to lose the publishers, but not to worry, we can select them again, and we will, but not right now. So we're going to go to your database tools here at the top. I'm going to go to relationships. And you'll notice, now these weren't in here. I'm just going to delete them for now. There's a couple of ways to get them in here. One of them, I'm going to close this down too, is to right click and say show table. And I can take this one, I can drag it in. All right. And that's good. The other way to do it, I can just drag it from the side here as well. All right. So within that, I can then make my connection here. Have the publisher's ID to the publisher here. All right. So you'll see it's a one-to-many. Now, I'm going to go back to that for a moment. And whoops, I got to click on it the right way. There we go. You notice I checked off enforce referential integrity. What that means is I must have a publisher in order to create a book. I don't have a publisher. Remember I tried to put publisher 4 in, it wouldn't do it? That's the whole point of this. Cascade, update, related fields. If something's changed, there's an update somewhere, it'll cascade that change. More importantly, the deleted fields. If I delete a publisher, all of those books will go. And the reason is I don't want to orphan data. I just don't want to do that. Okay, we don't want to do that. All right, so we're going to hit save here. We have to save and close this. Now, I'm going to go back to my books and add my publishers. Let's go to publisher 1. Let's go to publisher 3. Let's go to publisher 2, publisher 3, and publisher 3. Okay, so within that, now if I go to my publishers here, guess what? Interesting, right? I can now get that data that I want, right? This is important. It's very, very important to what's going on here, to be able to connect the data and link the data. While I'm here, go to datasheet view. I'm sorry, design view. Datasheet's what you're seeing. Design view is for design. We're going to go to properties. It's set for auto on the sub sheet, on the sub data sheet, but really our sheet is books. So if you had multiple relationships, you'd have to select which one you wanted to be your the sub data sheet here. But this is good. This is very important. Now I want to show you one more thing. All right, if I can illustrate this concept. If I delete this publisher, it'll ask me, "Are you sure they cascade?" I'm going to say yes. I'm going to go back into the books table. It's gone. All those books that related to that publisher are gone because we don't want to orphan data. Now, in terms of normalization, I want to get to that too in a minute. We're going to go back here for our final, and we're going to change this, the publisher's field from lookup to text and save it. Now you'll see my publisher is saving the publisher as a number. That's what it's referencing. And I can replicate that without any issue because I don't care here. So I'm going to put in publisher 3 just to illustrate this point. And what I'm going to then do here, let's see, we got Moby Dick, we got the Pit and the Pendulum. We're going to put the Raven in here. 1886, we'll call it. I don't care. We put in 4. It actually somehow took 4. I don't know how it took 4. I'm sorry, this is books, yeah. It shouldn't have taken 4. Oh, there is a 4. I'm sorry, it is 4. It is 4. I'll explain why that happened too in another video, but what happened is once I delete 3, it's gone completely from the auto number, and the next one comes up. So that's why. If I were to put in 5 here, say, sorry, it's not there. So if I were to put back 3, again, it would also say, sorry, that's not there. So 4 is there. So now when I come back here, and you're seeing, that boom, boom, and boom. All right, you're seeing those 3. So anyway, you've learned a little bit about normalization. You've learned that I can create relationships. Here's our relationship again. And you've learned here too that storing of data is not exactly as you would expect it. So please like and subscribe. I am the database guy. Keep it here. When we come to our next video, we'll be at video point 4, tables. It'll be a big one. You're going to love it. Probably be more than one video. And presentation 4, tables, more than one video. Keep it right here and have a great day, evening, night, wherever you are.